Unit 1 review. It's been some time since Unit 1. And the main skill that we covered during that unit was adding and subtracting fractions and mixed numbers. You may recall some concepts like borrowing from the whole in certain subtraction problems, finding a common denominator, simplifying your final answer, converting improper fractions to mixed numbers. Hopefully some of that is ringing a bell because you are going to see those old friends again today. Let's get started. We're going to focus on the word problems. And let's begin with number 1. 5 minus 1 3/7. Well, right off the bat, you notice, this is interesting. I've got a whole number, and then I've got a mixed number. What's the deal? Well, we are going to have to rewrite this whole number as a mixed number. And one way we can do that is by borrowing from the whole. We can imagine if the denominator that we want to work with is a 7, we can imagine looking at this 5 and breaking it up into a 4 and a 1. Imagine that. We're going to break this up into a 4 and a 1. 4 plus 1 is 5. But we're going to show the whole number 1 as a fraction that has a denominator of 7. What goes on top? Well, something over 7 equals 1. 7 over 7. Is this a fair move? Can I rewrite whole number 5 as 4 7/7? Sure I can. And now look at how that sets us up to be able to subtract. My fractions have the same denominator, and in this case, the numerator is greater than this numerator is greater than this numerator. And my whole numbers, I can have my dessert first. Let's do 4 minus 1 and get 3. We know the denominator of the fraction will stay as 7. And let's let the numerators do the work. 7 minus 3 gets us 4. We get a final answer of 3 4/7. Moving on to number 3. Subtraction. 6 5/8 minus 4 1/12. What's your first impression of this problem? If you notice that the denominators don't match, that's good. That gives us a clue about our first step. We need to find a common denominator, and then we need to use what we know about equivalent fractions to rewrite one or both of the fractions. To find a common denominator, look at the two denominators that are given, focus on the larger one first. Will 12 work for 8? In other words, is 12 a multiple of 8? No, it's not. Okay, now, can I go through my multiples of 12? If 12 won't work, what's the next multiple of 12? 12, 24. Ding, ding, ding. If you said 24, you were right. I can list my first few multiples of 8, 8, 16, 24, 32. I can list my multiples of 12, 12, 24, 36, 48. And we can clearly see that 24 is the first number that matches. So I'm going to rewrite both of these having 24 at the bottom. What I do to one side, I must do to the other. So over here, if I'm starting with 8, what do I have to multiply 8 by to get 24? Times 3. Let's do the same to the top. 5 times 3 is 15. 1/12. If I start with 12, what do I have to multiply down here? Times 2. Do the same up here. 1 times 2 is 2. Now the denominators match. This numerator is greater than this numerator, so it is set up for subtraction. Let's do our whole numbers first. 6 minus 4, of course, is 2. 15 over 24 minus 2 over 24 leaves us with 13 over 24. Number 5, 8 1/6 minus 4 1/5. Our denominators don't match. 6 is the larger of the two. 6 is not a multiple of 5, so 6 is out. But let's go through our multiples of 6 until we find one that will work for 5. 6, 12, 18, 24, 30. Ding, 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 ding. 30 is our winner. 1 over 6. I need to multiply the bottom by 5. Let's multiply the top by 5. 1 over 5. I need to multiply the bottom by 6. Let's multiply the top by 6. Oh, but hold it now. I'm subtracting, but I can't do 5 over 30 minus 6 over 30. I've got to borrow from the whole. To borrow from the whole means whole number 8 becomes whole number 7. And that whole gets added into the fraction. I'm going to add in 30 over 30 to what I started with. And all of this will result in rewriting it as 7 and 35 over 30. Over here, this mixed number stays as 4 and 6 over 30. And now we can do our subtraction. Whole numbers first. 7 minus 4 is 3. Fractions next. 35 minus 6 is 29. Moving on to number 7. 13 over 15 plus 3 over 4. Okay. Well, we need a common denominator. 15 won't work for 4, so 15's out. Go through multiples of 15 until we find one that will work for 4. 15, 30, 45, 60. 60 works. 15 multiplied by 4 is 60. So I need to multiply 13 by 4 to get my numerator. Side calculation. 4 times 3 is 12. 2 comes down, 1 gets carried. 4 times 1 is 4, plus the 1 is 5. Okay. Down here. 4 times what is 60? Well, actually 4 times 15. So for my numerator, 3 times 15 is 45. Now my denominators match. I add my numerators up. And you can do this as a side calculation or possibly mental math. 52 plus 45 is 97. The denominator stays as 60. Is that our final answer? What's that you say? Improper! That British nanny. She never left us, did she? She's right. 97 over 60 is improper. 60 goes into 97 how many times? 1. The leftover amount, or the difference between 60 and 97, is 37. And the denominator remains the same as 60. Our final answer is 1 and 37 over 60. Number 9. 5 and 6 sevenths plus 7 and 5 sixths. Our two denominators, 7 versus 6. 7's out. Go through your multiples of 7 until you find one that'll work for 6. And the one I landed on is 42. What we do to the bottom, we do to the top. Over here, 7 times 6 is 42. 6 times 6 is 36. Down here, 6 times 7 is 42. 5 times 7 is 35. We can, let's see. We can add our whole numbers. 5 and 7 is 12. We can add our fractions. 36 plus 35 is 71. Is this our final answer? Improper! It is not. 71 over 42 is improper. This gets converted into a mixed number. Let's see, 1 and I'm going to say 29 over 42. I try to do 71 minus 42 in my head, and I think it's 29. Just going to quick check that in my head again. Yep, I'm going with it. Now, this gets added to the whole number 12. And I get a final answer of 13 and 29 over 42. Number 11 actually looks like it is referring back to problem 10. So why don't we just do problem 10 instead and wrap this review up. A batch of trail mix has 3 1/3 cups of peanuts, 2 1/2 cups of almonds, 1 3/4 cups of cherries, 2/3 cup of coconut flakes. How many cups of trail mix are in a batch? All right, so we got to add up these measurements. We need a common denominator that's going to work. We're dealing with denominators of 2, 3, and 4. 4 is the largest of these denominators. 4 will work for 2, but it won't work for 3. So let's go through our multiples of 4 until we find one that will also work for 3. 4, 8, 12. Ding, 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 ding. So we need to rewrite each of these as having a common denominator of 12. So let's start with the peanuts. 3 1/3 becomes what we do to the bottom, we do to the top. If we're trying to get a denominator of 12, we'll multiply the bottom by 4 and the top by 4. Okay, let's go to the almonds next. 2 1/2. What we do to the bottom, multiply by 6, we do to the top. Multiply by 6. Next, the dried cherries. 1 3/4. What we do to the bottom, multiply by 3, we do to the top. And 2/3. What we do to the bottom, multiply by 4, we do to the top, multiply by 4. And now we are in business because we have rewritten each of these measurements with a common denominator, and we can begin to add them. I'm noticing something right off the bat. 3 4/12 plus 8/12. If I combine these two, I'm going to get whole number 4. So I'm looking at whole number 4. That's what I got from adding these two. 3 12/12 is whole number 4. Plus 1 9/12 plus 6/12. Add my whole numbers. 4 and 1 is 5. 9/12 plus 6/12 is 15/12. I'm almost there. This is improper. This gets rewritten as 1 3/12. And 3/12 can be reduced. Unit of measure, donezo.